Okay, class, we are on Chapter 6, Section 3 and 4, so I'm kind of combining two sections here. And this is the last method of solving systems of linear equations, and it's called elimination. So far we have done one method, which is graphing. We find that intersection point, and the second way was to use something called substitution, where we get x by itself or y by itself in one of the equations, and then we plug that into the other equation and solve for the actual intersection point. And so today we're going to do something called elimination. Now pause for a sec and read through each step to how to solve elimination, and then we'll just go into an example. So one of the different things about this method is the last time for substitution we got x or y by itself. This time we need to use standard form, and ax plus by is equal to c. So this time by elimination we always need to use the standard form. So I'm sure the procedure may sound a little bit confusing, but I think if we do a few examples then it might make a little bit more sense. So let's just jump down to the examples. So if we look at the first one, we have line A is 5x minus 1 is equal to 12, and line B is 3x plus y is equal to 4. So if we read through the steps, step 1 says write each equation in standard form, ax plus by is equal to c, and it's already in that form, so we're good to go there. Number 2 says, and number 2 is not necessary all the time, it says multiply one or both of the equations by numbers that would produce opposite coefficients of one of the variables. Now that'll probably in a few other examples, but if you notice the up and down, so what we're doing is we are doing an up and down problem. Okay, so we're looking at the 12 and the 4 for the c's, we're looking at the minus y and the plus y, and we're looking at the 5x and the 3x. And so if we look at the up and down, you'll notice that the minus y and the plus y, they're opposites of each other. And if you add these going up and down, negative y plus y would actually cancel out. That's good. Our goal is to cancel one of the variables out. And so you're adding the up and down, so 5x plus 3x is 8x, and then we cancel the y, so it's equal to 12 plus 4, which is 16. So now we just are left with the variable x. Great sign. Okay, so that's what step 3 is. Add the equations to eliminate one of the variables. And so once you've done that, now you just go ahead and solve for the x value. And once you do that, we get, in this case, that x is equal to 2. And so again, a solution is the same thing as before. We're looking for a coordinate point. So right now our coordinate point is going to be 2 comma something, this y. And so now we're going to take this 2 that we just found for x and plug it into either line A or line B. It really doesn't matter. So if you plug it into line B, then you have 3 times 2 plus y equals 4, and then you just solve that. Multiply 2 and 3 to get 6 plus y is equal to 4, then subtract 6 on both sides, and then we get y is equal to negative 2. So the y value of the coordinate point is negative 2, so my solution, meaning where a and b intersect each other, is 2 and negative 2. If you didn't get that, why don't you kind of pause and rewatch number 1. We'll definitely go over this the next day. If you feel like you got it, why don't you try example number 2 on your own, because there's actually no multiplying involved here. You can kind of just look up and down and go straight through. So you can pause for a sec and then see what will eliminate. So if you recognized it correctly, you'll notice that the y coefficient has a negative 5 and a positive 5, so when you add those up and down, those actually cancel. And if you continue to add everything else, you get 3x is equal to 18. And then go ahead, take a moment to solve for x. After you solve for x, I got x equals 6. So again, it doesn't matter if you want to choose line A or line B. I'm just going to go to line A just because it doesn't have a coefficient in front of the x. and then I'm just going to plug it back in. When you plug in 6 for the x into line A, you'll get that y is equal to 1. If you plugged it back into line B, you'll still get y is equal to 1. But regardless, we see that our solution is 6, 1. So that's kind of the simplest as it gets. If you look at example 3, you'll notice that when you add up and down, nothing will cancel. So this is where step 2, procedure 2, has to come into play. You have to multiply one of these things so that you get the opposite of one of the variables. So if you look here, there's a positive 6c plus 7d is equal to negative 15, and then another positive 6c minus 2d is equal to 12. I would like to change one of the 6c's into a negative. So if I want to do that, I'm going to multiply everything by negative 1 to one of them. I'll just do that to the first one. And so what happens, line A changes to negative 6c minus 7d equals positive 15. And so now this old line A just disappears, and now I'm dealing with a new line A. And so now you'll notice that the 6c and the minus 6c, if you add up and down, can actually cancel. And then we get negative 9d. Negative 9d is equal to 27. Divide both sides by a negative 9. And then d is equal to a negative 3. And so the d portion, I'm assuming that's our y, so that can now get plugged into, so now you can put that into any equation and you'll still get the correct c. So if you want to pick the one that we didn't really change, that might be the safest thing. So go ahead and plug that in, see what you get for c. After you plug in negative 3 for the d, I got c is equal to 1, and since it's not really an x and y, I'm assuming it's alphabetical, so I think the coordinate point is 1, negative 3. I think that's our final solution. So if you look at number 4, take a pause and see what you have to multiply by to get rid of one of the variables. If you notice that negative 6 and negative 2 are, negative 2 is a factor of negative 6, and you just have to multiply everything by negative 3, then you're correct. And once you distribute that, your line B turns into a positive 6 plus 12y is equal to negative 42. So then now line A and your new line B can be added up and down, and you can eliminate the negative 6 and the positive 6x. So why don't you go ahead and solve for y now. After solving, I got y is equal to negative 1. Let's plug that in to the equation that we didn't use and solve for x. My final solution, I got a negative 5 and negative 1 for my coordinate point. Why don't you try number 5 and 6 on your own? I'll go 1 at a time and do 5 on my own, so I'll kind of take little breaks here and there. Now you'll actually notice that it's not in standard form at first, so you have to subtract 3x on both sides to get it into standard form. And technically, I mean, even these two guys are not in standard form because the a is a negative, but that's okay. If you notice that the x and the y has the exact same coefficient to one another, something in your mind should trigger. If it doesn't click yet, why don't you multiply one of the equations by something to get the opposite of one of them? If you thought, hey, you know, I could multiply everything by negative 1, that's a good sign, so that you get the opposite of a negative 3x. Now, once you cancel this out and you start solving, you actually realize that the negative 3x cancels, but also the y's cancel, and so you get 0. You get a statement of 0 is equal to 6, because 1 plus 5 is 6. Now here, the variables disappeared, and so again, just like we've been doing all year, once the variables disappear, then we have two choices. It's either a no solution or it's an all real numbers. And that all depends on if it's a true statement. If this is a true statement, then this is an all real numbers, and that seems to be the case for number 5. Okay? Number 6, it looks like we'll have to multiply something. Why don't you try number 6 on your own, and then the entire solution will be shown in a few seconds. I wish there was a way to re-record some things, because I just recognized that number 5, I made the wrong conclusion, right? 0 is clearly not equal to 6, and that's a very wrong statement. 0 is, so this is going to be a no solution, but number 6, when I do everything, we get 0 is equal to 0, and so that's why my final conclusion is in all real numbers. Alright, so if you have any questions, just come to class with them tomorrow. Maybe try to re-watch some of the videos, and it might be possible that you have to multiply both equations by something in order to get something eliminated. Alright, we'll try some more examples tomorrow.